Write down next topic, mechanical properties of fluids. Okay. So fluid is nothing but anything that can flow. The first point is fluid is nothing but anything that can flow, and the second point is like it is liquid and gas. So what is the shape of the fluid? So it depends upon the container. Shape of the fluid depends upon the container. So in this lesson we are mainly talk about pressure and density. These are the two important words which we are going to use in this chapter. Okay, pressure as well as density. Okay, so completed. Take down. Okay. Right on the first topic. Fluid static. So two things we will discuss, fluid static as well as fluid dynamics. Okay. So fluid static is nothing but, what is the meaning of static? Rest. Okay, so the fluid is at rest. We'll talk first thing. So under this we'll talk about the first one, density. So density usually will denote by the letter rho or else d. Okay, so mostly we'll use this letter rho. So density is nothing but it is the ratio of mass and volume. So why particularly at 4 degrees Celsius means due to anomalous effect. Anomalous effect. Due to anomalous effect. If they ask what is the reason behind 4 degrees Celsius means due to anomalous effect. Okay. So what is the SI unit of this one? Relative density. Relative density. It is no dimension or no units, because density by density it gets cancelled out. So relative density doesn't have any dimension or any units. Done. Write down density of water. Density of water it is density of water is 10 power 3 kg per meter cube. 10 power 3 kg per meter cube. So if they are asking in gram per centimeter cube is nothing but 1 gram per centimeter cube. If it is kg meter cube, it is 10 power 3 kg per meter cube. If it is gram centimeter cube means 1 gram per centimeter cube. Write on the first note point under this density. Note point. If two liquids of mass m1 and m2, if two liquids of mass m1 and m2 and density rho 1 and rho 2, density rho 1 and rho 2, then so density mixture will be equals to m1 plus m2 by v1 plus v2. Okay. So here what they have given, density and mass they have given no in the point, mass m1, mass m2, density rho 1, density rho 2. So what is the thing they have not given here? Volume. So volume is unknown. If volume is unknown, then what we should do is, we know that density is equals to mass by volume. So volume can be written as mass by density. So can I say V1 is equals to m1 by rho 1 and V2 is equals to m2 by rho 2? Yes, no? So can I rewrite this? Density mixture will be equals to m1 plus m2 by m1 by rho 1 plus m2 by rho 2. This is the formula if volume is unknown. Done? So any doubt in this first point? So if volume is not given, I can rewrite in terms of mass and density. Next point is, if two liquids with volume V1 and V2, with volume V1 and V2 and density rho 1 and rho 2 and density rho 1 and rho 2, then so rho mixture will be, here what is the unknown thing? Mass is the unknown thing. So this is m1 plus m2 by v1 plus v2. So here mass is unknown. So can I write density equals to mass by volume? So in this mass will be equals to density into volume. So m1 will be rho 1 v1, m2 will be rho 2 v2. Any doubts here? So can I substitute this? So rho mixture will be equals to rho 1 v1 plus rho 2 v2 by v1 plus v2. This is my density mixture when mass is unknown. Completed. So this is about density. Okay. So what is the formula? Mass by volume. So relative density is density of any substance with respect to density of water. Okay. Yes, at 4 degree Celsius. So at 4 degree Celsius only we have given that 10 power 3 kg per meter cube. So if mass is unknown or volume is unknown, these are the two formulas. Okay. So only thing is you need to rearrange the formula and you need to substitute it. That's it. So the next one is pressure. So pressure is nothing but force by area. So the first one. Second point is, what is the SI unit? Newton per meter square or Pascal. Pascal. Right on next point. So sometimes they will give in terms of bar, BAR. Okay. So bar is not a SI unit. Pascal is the SI unit. Okay. So 1 bar is equals to 10 power 5 atmospheric pressure. 10 power 5 atmospheric pressure. Okay. And so how we can rewrite this volume in terms of area and length? Can I multiply area into length? That is nothing but volume. Yes, no? Suppose if they have given density equals to mass by volume, they have given in terms of area and length. Can I write mass is equals to density into area into length? Correct, no? Density into volume, no? So area and length. And if they are talking about a small mass, which means a small volume we will talk, density will remain constant. If I talk about water, so how much ever water if I take, the density of water remains constant, that is 10 power 3 kg per meter cube. If I take a small drop of water also, it is 10 power 3 kg per meter cube. Okay. Density always remains constant. If a liquid changes, density changes. I am talking about only water here. If I talk about oil, the density changes. If I talk about alcohol, the density changes. So depends upon the liquid, a density changes. If a same liquid, same density. So if we talk about the same liquid, means density will remain constant. Okay. There is no change in density. Only if we talk about dm, that is small mass. Dm is nothing but small mass. Okay. So can I write dm is equals to rho into dm times A into L? Like if I talk about small mass, I'll talk about the small volume. If I talk about only this part, no, this one will have some volume, right? Yes or no? Can I talk about that mass also? If I talk about the whole container, the liquid is there, no? Can I talk about the whole volume and whole mass? Getting the point? So we know the formula, density equals to mass by volume, right now? So can I write volume in terms of area and length? Yes, no? So mass will be equals to density times area times length. Any doubt up to this? Okay. And the third point what I have told, if a liquid changes, density changes. If a density changes, I can't say it is a constant. If a liquid remains constant, density also remains constant. If I talk about a 1 drop of water also or 1 liter of water also, the density will remain same. Okay. So 1 drop will have a different mass or 1 liter will have different mass. Yes, no? I am talking about only one drop which is small, okay. Then I will talk about a small volume, no, getting the point. This whole thing is volume, right. So d times, okay, d times a l. Any doubt here? Any doubt? From this, if area is constant, I can write this dm is equals to rho a into dl. Area is constant, no, I will take it out, only dl will be there. If length is constant, can I write dm is equals to rho l dA? Understood now? If they talk about area changes, then this formula. If they talk about length changes, then this formula, okay. You can take down. Completed? Completed? Okay. And this atmospheric pressure is there, no? This one we usually write in terms of P naught in this whole lesson. Throughout the lesson, we will use P naught as a atmospheric pressure. So wherever we see rho, it is a density, P naught, it is atmospheric pressure, okay. Right on, next topic, fluid pressure. Fluid pressure. So listen carefully. See, I have taken a container, in that a cylinder is there, okay. I kept a cylinder. So cylinder is having a mass m. So what will be the weight of the cylinder? mg, no? Weight is nothing but m into g, acting towards downwards, right now. So this cylinder is having two surface here. So this one, can I take this as area 1 as well as area 2? This is the first area and the second area. The surface is there, no? If I talk about this is a cylinder, the top part and the bottom part will be there, no? If I keep into the water, what happens? It will try to oppose it, and in the top surface it will try to push it down, right? No? So can I say two forces are acting? So one will be upward force, that is F1, and downward force F2. Correct? No? Any doubt here? Any doubt? So can I write the equation F2 plus mg will be equals to F1? Any doubt here? Any doubt? Anyone? Any doubt here? And if I multiply with area A2, A1, and can I write this in terms of density into volume? Yes, no? This is having a length or a height h. So mass is nothing but density into volume. So density into area into that is height h. Correct? No? Can I rewrite this one? AF2 plus rho AHG equals to F1A, and I am talking about the a cylinder which is having a constant area. Here also A and here also it is A. Any doubt here? So can I cancel this A? Can I cancel it? So F2 rho Hg equals to F1. Any doubt here? Any doubt? Anyone? Anyone is not getting here this point? Anyone? Array? Once again. Okay, listen carefully now. So there is a container in which a liquid is there. Okay, if I keep a object, any object, so from top, like the weight will be there, no, the gravity, it will try to push it down. So one force is acting upward and other force is acting downwards. Yes or no? And what will be the weight of the object? Mg. That also will be acting towards down. Any doubt up to this? Any doubt? Anyone? So this is a uniform cylinder I am taking. So area here and here it will be same. Now it is clear. And I have talked about the length of the cylinder is, or height of the cylinder is h. Any doubt here? So can I write this mass of the cylinder in terms of density and volume? Yes, no? Mass can be written in terms of density and volume is A into h. Any doubt now? Anyone? Now one force is acting in this direction, the other force is acting in this direction. Understood now? And weight will be downwards. This is mg, and if I talk about this is F1 or F2, whatever it is, and this is F2. F1, F2. Now any doubts here up to this? Can I write the equation? So downside will be 1 and others, like top side will be in other side of the equation. Can I write like mg plus F1 will be equals to F2? Understood? No? Copy down up to this. So what is the formula for pressure? Force by, can I write force is nothing but pressure times area? Any doubt? Can I replace this whole terms here in this equation? So rho A H G plus P1 A should be equals to P2 A. Understood? So can I write P2 is equals to P1 plus rho G H. Understood? Now, so P2 is equals to P1 plus rho G H. Write on the note points. So any doubt in the formula? So whenever we are talking about the height difference, no, the pressure will vary. So the top pressure is considered as P2 or P1 should be equals to P1 plus rho G H. Okay. So density will be given like whatever the liquid they will give. Okay. If they talk about water, you should write the density, that is 10 power 3. Okay, 10 power 3. Okay, sometimes they will say the word water, that's it, and they won't give the, or they won't mention the density. So in those cases you should consider that is 10 power 3. So the first application or first note point. So 3 cases will take. So object is having height h1, and from the water top surface to the object height is h2 we will consider. Okay, this is water surface, no, top surface, and object is inside the water. So h2 and this is h1. The next condition is object is exactly like this. So this is h I will take, or h1 whatever it is, and the third condition is it's a closed one. It's a closed one. Okay, so water is there in this also. Take these 3 conditions, I will say the formula. See, listen, one more point before that, we are talking about the application, no. So in this, no, it's an open surface, no, it's an open surface. So is this exposed to the atmosphere? Can I say the top pressure is nothing but atmospheric pressure? Can I write like this? P2 is equals to, or P is equals to what? P is equals to P naught plus rho g H. P is nothing but the pressure at the bottom. This pressure I need to find. Okay, P or P2. So if they are asking what is the change in pressure, change in pressure is nothing but delta P will be equals to P2 minus P1, that is equals to rho g H. Okay, this change in pressure is nothing but gauge pressure. Gauge pressure. Okay, it's a gauge pressure. Now listen, I will give time to write. Now if we talk about here, this is an open surface. The first condition is open surface. If I want to find what is the pressure at this point, so P2 will be equals to P1 or P0 plus rho g. H is nothing but like the height difference I need to get it, right now, H1 minus H2. This is the formula for the first condition. Second condition is P2 will be equals to P0 plus rho g H1. Okay, only this height only, no. And the third condition, this is height H1 and this is height H2. Is this a closed container or open container? What about atmospheric pressure? There is no atmospheric pressure. Can I say P0 is equals to 0? So P will be equals to rho g H1 minus H2. Okay, three conditions. So two open condition and one is closed condition. In closed condition, atmospheric pressure is 0. Only the water we are talking. So P will be equals to rho g H1 minus H2. In this two, atmospheric pressure will be there. Okay, write down. Write on this point also, the gauge pressure also. Write down. Completed? Write on next topic. When the container is accelerated, when the container is accelerated. So under those two conditions we'll see. The first one is vertically upward or downward and one is in horizontal direction. Okay. So vertical direction, horizontal direction. So only two direction, no. we will talking. So either it can move up or it can move down or it can be right or left. Okay. So vertical direction or horizontal direction. So write down the first one, vertical direction or vertically accelerated. Vertically accelerated. So under vertical acceleration, two conditions, container is moving upward, container is moving downward. Okay. So in this, gravity is there, here also gravity is there. So what is the thing we have talked about the vertical acceleration in laws of motion? I should talk about the effective acceleration. No, if both are in opposite direction, I should add it. If both are in same direction, subtract it. So what is the formula? P is equals to P naught plus rho g h. So this g, no, we are talking about g effective. Okay, g effective we should talk. So here g effective will be nothing but a plus g, and here g effective is a minus g. Then what will be the formula? P will be equals to P naught plus rho into a plus g times h, and here P will be equals to P naught plus rho into a minus g times h. Clear? Write down. Completed. So now it is horizontal direction. Okay. Suppose this is my container, okay, and the container is having a water up to this level. If we talk, so this is at rest. Okay. If it starts moving with acceleration a, then can I say the water is going forward like this? Yes, no? This will be my level of the water. So F2 minus F1 will be equals to the mass into the acceleration. Okay, mass into acceleration. So can I write pressure P2, the change in area, minus pressure P1, change in area, should be equals to density into change in area into the length L. Correct na? Yes or no? Into acceleration A. Can I cancel this? So P2 minus P1 equals to rho L into A. Okay, rho L into A. And from this diagram, can I write tan theta is equals to H by L, opposite by adjacent. So can I write L is equal to H by tan theta? Any doubt here? And can I substitute that here? Any doubts? This is about the horizontal, and this A is nothing but acceleration of the container. Acceleration of the container. Take down. So any doubt up to this? Write down note point. See, listen. So in this point we will discuss about the different container, but the level of the water or liquid at the same height. Okay. So like different container, like different shape of the container we have taken, but when we talk about the height of the liquid, no, it is at the same height, and I have taken the equal point, like the same level of the point A, B and C. If they are asking what is the pressure of A, what is the pressure of B and what is the pressure of C, okay. So pressure of A, pressure of B, pressure of C, right now. So if we talk about this is the lowest point and this is the highest point, that is nothing but P naught, no, atmospheric pressure. Can I write PA will be equals to P naught plus rho GH, the same liquid I am taking, water only. Similarly, can I write PB is equals to P naught plus rho GH? Any doubt here? And similarly PC will be equals to P naught plus rho GH. P2 is equals to P1 plus rho GH, the formula we have derived, na. So according to the height we have taken the pressure A, B and C. So since we are talking about the same level of height and same point, can I say pressure A will be equals to pressure B will be equals to pressure C? Since the height are same, it can be any kind of container. Since the height are same, I can say the pressures are equal. If I talk about this pressure, this point A1, point B1, point C1, so everything is same height, no. So can I say A1, A2, C1, I mean A1, B1, C1, everything are equal? Any doubt here? Write on the first point, then you can take the diagram. All the points, heading, note point, all the points at same height, exert EXERT, exerts same pressure, in bracket if density is same, and you can take the diagram now. Completed? Okay. The next note point. Listen here. So there is a YouTube, okay? Not that YouTube, okay? U-shaped tube, okay? So in this, there is a 3 different liquids, okay? This is density 1, density 2, and density 3. So this is up to the same level, okay? And they are asking what is the pressure at A and pressure B. So can I talk about only this point now, as of now, which is nothing but PA will be equals to P naught plus rho G, so rho 1 G H1. If I talk about only this point, PB will be equals to P naught plus rho 2 G H2. Since the last point we have discussed now, when the height is same, like when I talk about the pressure at the same level, both will be equal. Can I write PA equals to PB? Yes, no, according to the last point. The same height, no? Okay, same height in the sense like pressure will be same. That's the point we have discussed. Now can I write PA is equals to PB? And if I substitute P naught plus rho 1 G H1 should be equals to P naught plus rho 2 G H2. P naught and P naught will get cancelled off. G and G also will get cancelled off. Yes, no? So rho 1 H1, or if anyone having doubts, no? First I will cancel these two things. I will write rho 1 G H1 equals to rho 2 G H2. Now I will cancel this G and G. So rho 1 H1 will be equals to rho 2 H2. Okay. Any doubt in this point? You can take down. Listen. So in the previous case we have talked about only two liquids, okay, upon the pressure B as well as pressure A. Now if we talk about pressure A, no, one liquid is there, and pressure B, two liquids are there. So in this, no, what happens is, like in the previous case only we have derived, like rho 1 H1 will be equals to rho 2 H2. Here rho 1 H1 will be equals to rho 2 H2 plus rho 3 H3. That's it, when the three liquids are there. So I am talking about this 2 will be equals to this one, okay. Note point number 2, application, you can take it. Write on next topic. Pascal's law. Pascal's law. So under Pascal's law, the first point, under Pascal's law, the first point, the variation in pressure, the variation in pressure, the variation in pressure at any one point, at any one point, the variation in pressure at any one point in an enclosed liquid, in an enclosed liquid is equally varied, enclosed liquid, pressure at one point in an enclosed liquid is equally varied, V-A-R-I-E-D, varied at all points of the liquid, at the all points of the liquid, equally varied at all points of the liquid. So the general application in day to day life now, for example, So let me take this area A1 and this area A2. Okay. And here some force F1 is acting, and here the force will be F2. So where we are seeing this kind of applications, no, like the vehicle washing, like car washing or any kind of vehicles. If I apply a pressure on one side or the force on one side, the equal force will be lifted other side, no? Yes, no, if I apply pressure on one side, and the second side will be equal pressure, okay, to lift the car. Okay. So can I say that pressure is nothing but P1 and this pressure is nothing but P2. Pressure at all points are equal, no? So P1 is equals to P2. What is pressure? Force by area. So can I say F1 by A1 is equals to F2 by A2. This is the Pascal's law. Okay. Area can be anything. The pressure will be same. Completed? Buoyancy force. Okay. Right on the first point. So buoyancy force always acts upward. So buoyancy force always acts upward. Okay. So if we talk about any object placed in the liquid, so buoyancy force will be in the upward direction. Okay, upward direction. And we know that let me take this object is having mass m, then it will be mg. Okay, mg. So in this there are conditions. If a ball or if an object sinks completely, or object is floating, or object is in the equilibrium condition. Three conditions are there. Okay, listen carefully, afterwards you can take down. So first thing, object has been sink completely. Second condition is object is floating. Third condition is object is exactly in the middle position of the container. Okay. So three conditions. In the first condition, can I say the mass of the object is greater than the buoyancy force? Yes, no? So mg is greater than fb. In this condition, fb is greater than mg, no? Yes or no? In this condition, can I say mg is equals to fb? Any doubt here? Three condition. If object is sinking, the mass of the object is greater, or the weight of the object is greater than the buoyancy force, and if object is floating, in the sense buoyancy force is greater than the weight of the object, and if it is in equilibrium condition, both are equal. Okay, so this is sink and this is floating and this is in equilibrium condition. Three conditions. Okay, any doubts here? Write down. Completed? Now we will derive the formula here. So buoyancy force equals to the mass of the solid into the gravity, right? No? So can I write this mass in terms of density and volume? Yes, no? So density of the solid and volume and into gravity. Any doubts here? Any doubts? Take down the first point. Write down. Completed. Now we have talked about the equilibrium condition, no? We have talked about equilibrium condition, no? So if I talk about the liquid, liquid is having volume, liquid is having density, right? No? So can I write the other terms? Fb is equals to volume of a liquid which is present inside the container. Okay, so volume inside the container and density of the liquid and the gravity. Any doubt? Two things, like one force is acting downwards, other force is acting upward, correct? No? So if I talk about two forces, both are equal force, we have talked, no? If equilibrium condition means, yes, no? So can I equate both of them? So this is total volume. So density of solid, volume of the total, and G will be equals to volume which is in the container, density of the liquid, and G. So G and G will get cancelled. V total will be equals to volume which is present inside the container after displacing the object, density of the liquid by density of the solid. Take down. So if they are asking what is the total volume present inside the container after displacing the ball, okay. So V total will be equals to volume which is present inside the liquid, I mean inside the container, and then density of the liquid by density of the solid. So if they ask what is the formula for the buoyancy forces, V rho G, that is it. F is equals to V rho G. In terms of mass, no, like we are taking density and volume, that is it. So F is equals to V rho G will be the density, like formula for the buoyancy force. So any doubt up to this? Up to this any doubt? So as I told in the starting of the class, two topics are there. One is fluid statics, fluid dynamics. So up to now the fluid static has been completed. Okay. Now we will go into the topic fluid dynamics. So dynamics is nothing but a fluid is in motion. Fluid itself in motion. Okay. Like the water is flowing or liquid is flowing. Okay. Right on the next topic. Completed. Completed this one. Fluid dynamics. So in this we will talk about fluid flow. In this we will talk about fluid flow. So under this two things are there, laminar flow and turbulent flow. Laminar flow and turbulent flow. So under fluid flow we will talk about laminar, turbulent. So laminar flow is nothing but, listen, laminar flow is nothing but when a fluid is flowing, no, a fluid will flow with layer by layer. For example, if I talk, the first layer is there, second layer, third layer, fourth layer, fifth layer, okay. Like the layer by layer, like there is no disturbance between the fluids, first layer, second layer and third layer. But when I talk about a turbulent flow, no, it is zigzag, okay. The fluid will be in a zigzag motion, okay. For example, let me take a particle 1, 2, 3. So this particle will go in a parallel in the like laminar, okay. It does not disturb the first particle with the second particle. But when I talk about the turbulent, if I consider two particles, it will keep on disturbing each other. It will be keep on disturbing each other. If I talk about laminar, no, it is not only about straight line, it can be any curve also. So two things, laminar flow, turbulent flow. Laminar flow will be a layer by layer, it will be there, okay. Turbulent will be, it will be in a zigzag motion, okay, zigzag motion. So for like a laminar, no, there won't be any disturbance between any particle, it will go in a smooth manner, okay. But turbulent, it will be keep on disturbing the other particles, okay. if I talk about the first layer, some particle is there, second layer some particle is there, and third layer some particles are there. So the first particle will keep on disturb the second particle as well as third particle, then it is a turbulent flow. Okay. So in this there is no disturbance, only you need to know what is the difference between them. Okay. So like to find what is turbulent or what is laminar flow, we are using a Reynolds number. Okay, a Reynolds number, so that is not in the portion. Okay, it is removed completely, so it's not in the portion. So only the like the theory part, like what is laminar and what is turbulent. Okay, zigzag motion, it's a parallel, we can say. Okay, it will go in a parallel, but it's not only about a straight line, it can be a curve also. Any doubts here? Take them. So under laminar, the first point is fluid goes layer by layer, fluid goes in layer by layer. Second point, it's also called as streamline flow. It is also called as streamline flow. It is also called as streamline flow.